In this video, we will demonstrate how to conduct GNSS receiver tests using the N7609APPC GNSS embedded application. This solution supports commercial GNSS receiver tests for wireless or automotive customers. The GNSS receiver testing system consists of the M9484C VXG vector signal generator, the N7609APPC GNSS embedded application, a real GNSS receiver, and receiver software tool running on the PC. The GNSS application runs on the M9484C VXG. It can simulate multi-constellation and multi-band GNSS signal generation in real-time control mode. The receiver connects to the signal generator via the RF cable, and you can view the test results using the receiver software tool. Let's take a quick look at the key features of the N7609APPC GNSS embedded application. The user interface is clean and intuitive, making signal configuration straightforward. It supports multiple constellations and multiple frequency bands, allowing you to select the desired bands for each constellation, which will apply to the generated signal. The Scenario Settings feature allows you to create various scenarios for your receiver test. Two scenario types are supported: static for a fixed location receiver and dynamic for a moving receiver. For static scenarios, you need to provide the longitude, latitude, and altitude of the fixed location. For dynamic scenarios, you need to specify a trajectory file containing a time-stamped sequence of locations. The almanac file includes the orbit parameters for each satellite, which helps to calculate the satellite position in the sky. You can download the almanac file for the day one to simulate, as specified in the start time parameter. Atmosphere modeling is enabled for scenario generation, and you can edit the parameters when necessary. The GNSS application supports real-time satellite control. By tapping Satellite Settings tab, you will see a list of all visible satellite settings for each constellation. During the simulation, you can turn the satellite on or off by checking the Enabled box and adjust the power levels based on your testing needs. This real-time control allows you to model impairments like power loss or visibility issues due to obstructions, enabling to quickly assess their impact on the receiver. There are various graphical displays for real-time status during the simulation, which are useful for GNSS customers. The first display shows the UTC time indicating the ongoing simulation time. The most important view is the real-time sky view, where we can see all visible satellites. Hovering over a satellite reveals the real-time information about its position, pseudo-range, Doppler, and power level. Satellite position is expressed by a two-dimensional value pair: elevation angle and azimuth angle, both of which change over time as the satellite moves rapidly in its orbit. The real-time power view shows the power levels of individual satellites. Note that different bands are shown separately. For the dynamic scenario, there is a real-time trajectory view that shows the current location of the GNSS receiver on Earth, along with its speed and heading direction. The antenna pattern view lets you specify antenna response patterns to simulate the characteristics of a receiver's antenna or to account for environmental obstructions. Now let's proceed with the demonstration. First, we'll perform an instrument preset and then launch the GNSS embedded application. We'll create a static scenario using the default position by enabling the state to generate and play the GNSS signal. Next, we'll turn on the RF output of the VXG. In the sky view, we can observe the visible satellites. Now we switch to the user interface of the GNSS receiver software tool. We'll perform a cold start TTFF test on the receiver and wait until it reaches fixed mode and provides a valid TTFF result. During this test, it may take 20 to 30 seconds to achieve the first fix. Checking the location calculated by the receiver using multi-constellation and multi-band satellite signals, it should match the settings on the GNSS application. Let's return to the GNSS application to create the dynamic scenario for moving receiver. We'll disable the state and select dynamic scenario type. For this example, we'll use the trajectory file circle.gga from the example folder and enable the state again. Next, we'll switch back to the receiver software tool, clean the display, and perform another cold start. The valid TTFF result will be displayed, and the receiver trees will form a circle, matching the trajectory in the GNSS application. Here, we've clipped the speed by a factor of 20 to illustrate the moving trees. Let's quickly review the features. To ensure thorough testing of GNSS receivers, it's essential to simulate multiple GNSS constellations and multi-frequency bands, while accurately modeling various impairments in satellite signals, like atmosphere distortions. Real-time GNSS signal simulation is critical, allowing dynamic adjustments to satellite visibility, power levels, and other conditions the receiver may encounter in real-world applications. Various graphical display provides you sky view, power view, and trajectory view, which are useful to check real-time status during simulation. SCPI commands are also supported, enabling test automation. The Keysight N7609APPC GNSS embedded application running on the M9484C VXG vector signal generator offers a real-time satellite simulation solution and helps you meet the challenges of modern GNSS receiver testing. That's all for today's video. Please visit k.com for more information. Thanks for watching.